Okay, this is from WebWork 5, problem 14. It states that our starting out, we have 300 fish, and our carrying capacity, or K, equals 5,000. And then after 1 year, the amount of fish triples. So 300 times 3 gives us 900. And it also gives us dp over dt equals kp, and this is a little k, not the carrying capacity, 1 minus p over k, which is the carrying capacity. So right from there, the first thing we want to do is find k, this k right here. So first we can start out by subbing in for this k, which is 5,000, and get dp over dt equals kp 1 minus p over 5,000. And then from there we can separate the variables. So dp over p times 1 minus p over 5,000 equals k dt. And then integrate both those sides and get ln of 5,000 plus p plus ln of p equals kt plus our constant. And then from there we can simplify this to be ln of p over p minus 5,000 equals kt plus c. And then from there what we can do is take the exponents of both sides to get rid of this ln right here. So then we get p over p minus 5,000 equals e to the kt. And then we're going to throw in our c1 here, where c1 equals e to the c. So then, from there, we can simplify it more to be p over c1 e to the kt equals p minus 5,000, and then just keep simplifying. So c1 e to the negative kt, because I brought that up, times p equals p minus 5,000, and then p plus c2 e to the negative kt times p equals 5,000. Sorry, I lost my place. So then we do p plus c2 p times 1 plus c2 e to the negative kt equals 5,000, and then we get pt equals 5,000 over 1 plus c2 e to the negative kt. So now we have to find two things, the c2 and then the k, which was the original question. So we already know that p of 0 equals 300, so we can substitute in. So 300 equals 5,000 over 1 plus c2 e to the negative k, and t is 0 in this case. So then we get 300 equals 5,000 over 1 plus c2 times 1, because e to the 0 is 1. So now we can simplify that to be 1 plus c2 equals 5,000 over 300 1 plus C2 equals 5,000 divided by 300, which is 16.66 repeating. So then we subtract over that, and C2 equals 15.66 repeating. So now we can sub that back in to get PT equals 5,000 over 1 plus 15.66 repeating e to the negative kt. So we're still looking for that negative k. But we also know P1 equals 900. So from there, we can do 900 equals 5,000 over 1 plus 15.66 e to the negative k times 1, because that's our t, and simplify that to get 1 plus 15.66 repeating equals 5,000 over 900, which will then simplify, oops, I forgot my, okay, right, yeah, e to the negative k, I forgot in there. So then this simplifies 1 plus 15.66 e to the negative k equals 5.5 repeating. And then again, we can just keep on simplifying. So subtract the 1 over, and then divide. 4.5 divided by 15.66. And then to get rid of this e, we do the ln of this, which gives us negative k equal to negative 1.235. So then divide by negative 1, and this is our answer to part A. So A part 1. And then next we want to find PT. So we already have that PT equals 5,000 over 1 plus 15.66 e to the negative k times t, which you can see up here when I just replaced it. And then now we have our negative k, or our k, so we can just substitute that in. 1 plus 15.66 e to the negative 1.235 t. So this is our answer to part 2. So next it asks us how long it will take the population to increase to 2,500. So we want to find t. So 2,500 equals 5,000 over 1 plus 15.66 e negative 1.235 t. Okay, so then with simplifying, we can get 1 plus 15.66 e to the negative 0.1235 t equal to 5,000 over 2,500, which gives us 2. So then we're going to subtract this 1 over and get 15.66 e to the negative 1.235 t equals 1. And then divide. Negative 1.1235 t equals 1 divided by 15.66, which roughly gives us 2. So, well, then we can do the ln of both sides and get negative 0.1235 t equals that equals roughly negative 2.75. And then we can just divide. We get t equals 2.228 years, which is our answer to part B. And that's it.